All right, few things to take care of. And I know juniors, you love this. You just finished the ACTs yesterday, and now I'm going to talk about the MCAs. And that's because the MCAs are Monday and Tuesday of next week. And on the backboard this morning, I started to organize what everybody's going to have to do. So for third hour, juniors, you're going to stay right in here. We're going to do the MCA testing here in the classroom. But everybody else is going to go to the media center. So any non-juniors will leave the classroom and go to the media center. They'll take attendance again when you get to the media center, just to make sure that everybody's showing up where they're supposed to. But juniors, we're testing right in here for both days. And for both days, everybody else will go into the media center. Bring your Chromebooks, make sure they're fully charged, all that good stuff. One of the rules that they have, which it's just one of their rules, I can't tell you why they came up with it, but you can't have your charger on while you're taking the test. I don't know why that is, but you have to have it fully charged when you come in. Are they separate? Yes, totally and completely separate. In fact, all of them are. It's like the science tests now you take when you take the course that needs that test. So yeah, everything is separated. We will just do math for 2 days in here on the MCA math test. Usually, I'm going to say usually because I don't know that they've made a change, but that's usually part of the English class. The English class takes care of the reading. What's the other one? Yeah, reading and writing. They're responsible for both of those. So, okay. And I don't think anybody gets double tested. 9th grade, is that when you take the writing one? Or is that the reading one? Oh, that's right. This year's juniors, oh, it's a big mess. Yeah, so ask each of your teachers for, English, say, when are we going to end up taking the reading and writing, and then in math, we're taking care of the math, and then your science class. When you take that science class, that's when you take the science MCA for that one. So, it's a big mess given the whole COVID thing. What we need to cover today is we're going to start section 8.5. And I noticed that, and I have 3 classes of Algebra 2 students, which would be somewhere around 85 students or so. And as of this morning, only 26 people had taken the formative for yesterday. So write yourself a little note. Remember, formatives don't go in the grade book, but they're going to help you prepare for the test. So there's a little formative on the Schoology page that you need to go to, and you need to complete that. That was your only assignment for yesterday. I think it's like 6 or 7 problems. That's all it is. Okay. Alrighty. Section 8.5, I had talked to you about the fact that multiplying and dividing fractions is actually easier than adding or subtracting. So you should know this is going to take a little more work than what we were doing with the factor and cancel business. This takes a little bit more. So we're going to add and subtract rational expressions. And this is the kind of problem that this would help somebody figure out. At 3 p.m., 4 runners all leave the starting line, running laps around the indoor track. If the runners maintain their pace, at what time will Sue, Drew, and Stu finish a lap together, albeit exactly the same place at one time? At what time will all 4 runners finish a lap together, and explain your reasoning? And that's because some people are faster than other people, and you have to figure out when are they going to actually end up all at the exact same place at the same time, which would involve fractional times. Since you can see here, Sue is at, I don't know if that's an hour, 30 minutes. I would guess it's a minute, 30 seconds. And so you'd have to use fractions as you go through that. All right, down here. We can use common multiples to add and subtract rational expressions. We can also use common multiples of numbers to add and subtract fractions. We know that if we wanted to add 1/2 to 3/4, you have to have a common denominator. And so what we do is we try to find the least common multiple, the LCM or LCD, least common denominator, when we want to add these together to reduce the amount of work that we have to do. So multiples, common multiples is what we're looking for. Let's just say that it is 1/2 and 3/4. Now I know that's a little too basic because you're all looking at that and going, so the least common denominator would be 4. But what's really happening is we're thinking multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, just running through those numbers in our head. And then for 4, 4 times 1 is 4, times 2 is 8, times 3 is 12, etc. And we always want the smallest one if we can. So we look at these two lists and we say, what's the smallest number here that shows up on both these lists of multiples? There's our least common multiple, which will also be our least common denominator for 1/2 and 3/4. But what if there's also algebra involved? What if they're not just numbers in the denominator? What if there's x's and y's and all that good stuff? Well, it's the same principle. We have to have the least common denominator, but it might take us a little bit more work to figure out what that is. So our essential understanding is to operate with rational expressions. You can use much of what you already know about operating with fractions. Have to have a common denominator, hopefully the least common denominator. That's what we have to figure out. Once we have that, we can build up our fractions so they end up being the same. John, do you need a packet? Is there anybody else that needs a packet since I'm going to go dig one out? Hopefully I didn't take one that I already dug a packet out of. Six, there's 7. Aha. There you go, yeah. All right, add and subtract, common denominator. Best case scenario, the smallest one, least common denominator. So the first step when we're talking about algebra is we're going to factor the denominator. We want to see what are all the parts that made up this denominator so we can figure out, hey, do these two have anything in common already? You know, is there something less we can do because they already share something? Then what we have to do is we have to build them up to have that same denominator. So we have to have every piece of the denominator, whether or not it's in parentheses or it's just an x sitting there by itself, and it has to be represented in the LCD, and it has to be there to its highest power. Because here's what we can do with fractions. We can manipulate them by multiplying by 1 in different forms to make sure that we get a common denominator. Because we can't add, we can't subtract until we have a common denominator. So we're going to think about all the parts that make up our denominators. There might be some numbers hanging out by themselves. So that part will just be like, 1/2 plus 3/4, where you'd say, oh, 4 would be the LCD. There might be some variables that are off by themselves, just an x, just a y. And then we might have some factors and grouping symbols. We might have some binomials that we have to use. So everything has to be there, and it has to be there to its highest power. So to start with today, they're not even going to give us fractions. They're just going to say, let's just figure out what the denominator would be. And in this case, they're referring to this as the least common multiple, because that's what we do for our denominators. So what's the LCM of 12x squared y times the quantity x squared plus 2x plus 1 and 18xy to the third times the quantity x squared plus 5x plus 4? They told us step 1, you have to factor. If you can factor it, factor it. All right, well, this is all broken up already. There's nothing I can do there. Hey, There's no greatest common monomial here, but maybe this is one of those perfect square trinomials. This is x squared. That's 1 squared. Got to check the middle term. So to do that, I'd have to take x times 1 and double it. And if it matches the middle term, it's a perfect square trinomial. Well, x times 1 is 1x. If you double 1x, you get 2x. Hey, it is one of those fancy perfect square trinomials. That means I can write it as x plus 1 squared. So in factored form, this is what the first expression that they gave us would look like. Well, now I have to see if I can do any of that for the second one back here. All right, 18xy to the third. Any greatest common monomial factors that I could take out of that? Nope. Ooh, might be a perfect square trinomial again. This is x squared, and this is 2 squared. If you take x times 2 and you double it, what do you get? Oh, well, that's not the middle term. That's. Well, it doesn't mean it's not factorable. It just means it's not special, because that would have made it a special perfect square trinomial. So let's see. Is there some good old-fashioned factoring that we can do that would give us two numbers that multiply to 4 and add to 5? Yeah, 4 and 1. So it's still factorable. It just wasn't anything special. It wasn't perfect squares. Now, that's the start of this problem. Because the second part of this is we have to have everything, and we have to have it to its highest power. So let's take a look at what we have. Number part. 12 and 18. We have to figure out the smallest number that both 12 and 18 would go into. Well, it's not 18, because 12 won't go into 18. 18 times 2 is 36. Does 12 go into 36 evenly? We just found our least common multiple for the number part. Next thing we do is any stray variables that are not part of parentheses. Oh, well, we have both x's and y's. So we're going to need x's and y's. You have to take them to their highest power. So what was the highest power of the stray x's? So we're going to have to use a 2. And what's the highest power for the stray y's? Going to have to use a 3. Because remember, we can build these up to make them the same thing. What we can't do is tear them down. All right, so we took care of stray numbers. We took care of stray variables. And then they said we have to use any of those factors to their highest power. Well, I'm going to have an x plus 1. And I'm going to have an x plus 4. Hey, I already have an x plus 1 on there. I have to take them to their highest power. So which one of these needs an exponent? X plus 1, because it was squared in this one. If these were the denominators to a fraction, that is the very awful least common denominator we would need to have. So we should be very grateful they didn't actually give us fractions that had those for their denominator right now. This is just, hey, figure out what it would be. Figure out what that common denominator would be. Well, let's go down here. These don't look quite as bad. The God at 1a has 2x plus 4 and x squared minus x minus 6. Have to have them in factored form. Is there a greatest common monomial factor for this one? Yeah, let's factor the 2 out. No other factoring we can do with that one. I look at the second one. There isn't a greatest common monomial factor. There's nothing I can take out of all of those. Negative 6 is not a perfect square, so there's nothing fancy about it. So we just have to try some good old-fashioned factoring. What two numbers would make that one work? -3 and +2. Well, let's go through it. Let's find our LCM. Are there any numbers, stray numbers, hanging out by themselves? Oh, the 2. Gonna have that. Any stray variables hanging out outside of parentheses? So we don't need that this time. Now we need to have the parentheses there. But I have to figure out whether or not I need to increase the power on either one of these. Well, to figure that out, were there any powers up there that were bigger than 1? So we're done. There weren't any. This is the first factor, and this is to the first power since we didn't have to put it there. This is the second one, and this is to the first power because we didn't have to put it there. So that would be our least common multiples. Oh boy, look at B. B, they're going to give us 3 of them to look at. We have x squared plus 3x minus 4, x squared plus 2x minus 8, and x squared minus 4x plus 4. All right, just looking at the black one. Is there a greatest common monomial factor we could take out all those? Well, maybe it's a perfect squared trinomial. Oh, wait a second. -4 is not a perfect square. 4 is, but not -4. So this must be some old-fashioned factoring. What 2 numbers would make that work? First one, all factored. I look at the red one. No greatest common monomial factor. -8 is definitely not a perfect square, so we're back to good old-fashioned factoring. What will make that one work? +4 and -2. 2 down, 1 to go. X squared minus 4x plus 4. There's no greatest common monomial factor. Ooh, that might be a perfect squared trinomial. This is x squared. This is 2 squared. If we multiply that together and double it, do we get 4x? We do. Now you might say, but it's a -4x. Don't care about the sign. I just care, is it a numerical value of 4x? It's there. Because when we factor this, it's going to be an x and a 2 squared. If we need the middle term to be negative, all we do is put a negative in here. Subtraction. Now we've got it. All right, that's step 1. We factored like crazy. Step 2. Any stray numbers hanging out by themselves? Any x's and y's that aren't part of parentheses? Well, then we better write down what's in the parentheses. We're going to need an x plus 4, an x minus 1. We already have x plus 4, an x minus 2, and an x minus 2. But we need them to their highest power. Were they all first powers this time? Nope. We had a bigger one. Which one has the bigger one? X minus 2 is going to need the squared. So this is probably what's going to take you the longest to add and subtract fractions, is figuring out, well, what's my least common denominator? Once you get that, then it works just like fractions with numbers do. So it takes some time, and you will have some problems in your homework that are just like this, where it says just find the LCM. You know, you're not even doing any fractions yet. But then, of course, we will do some fractions. Because when we talk about our rational expressions, rational is ratio, and in math that means fraction. So the least common denominator of the fractions is also the least common multiple. But when we work with fractions, we've always called it the least common denominator. But it is truly the least common multiple. Now, they're giving us kind of a different way of looking at this, because they're saying, what happens if your denominators get to be really big numbers? Well, most of the time, we're able to find them anyway. I think with 8 and 10, most people would go, okay, 10's not going to work. How about 10 times 2 is 20? No, that's not going to work. 10 times 3 is 30. Nope. 10 times 4 is 40. Oh, 8 goes into 40. You know, that's the type of thing that we do. But they're showing us that we could make a little factor tree out of it, and then we could build up the denominators to 40 as well. Most of the time, we're not going to need that. They're just showing us it's another way of doing it. So now, let's see what we're supposed to do with all this. What is the sum of the two rational expressions in simplest form? State any restrictions on the variable. All right. Well, that first little fraction there, that's done. I mean, I can't factor x minus 1. That's a factor. It's done. But not the second one. X squared minus 3x plus 2. No greatest common monomial factor. Not a perfect square trinomial, but maybe some good old-fashioned factoring will work. What will that factor into? Multiply to 2 and add to negative 3. Negative 2 and negative 1. So right now, we have some things to figure out. The first is exactly what we just did in the last couple of problems. We need to figure out the LCD. Now, it bothers some people that the x minus 1 is not in parentheses. Put them on there if it bothers you. X minus 1 is x minus 1 to the first. Put them on there. So now, we don't have any numbers in the bottom, right? Hanging out by themselves? Any x's or y's that aren't in parentheses? So we're just going to need the factors. We need an x minus 1, and we need an x minus 2. Are any of those to a power greater than 1? Then that is our LCD. That is also where we're going to find our restrictions, because this is going to be our common denominator. So for our domain, we have a couple numbers we have to leave out. Because what can't we divide by? Yeah, so we have to watch out. So what number, if you put it in here, is going to make this 0? 1. X can't be 1. That would be bad. How about this one? What's bad? 2. It's out. Now, let's just say, because I know this happened, a couple of people were asking questions about it. Let's just say our LCD ends up with something like this. 3x minus 1. There were a couple of people that said, okay, Cedarholm, that one's harder. How am I supposed to figure out what the 0 is? Do this and you'll get it. As soon as you write that, your brain is going to go, oh, I'd add 1 and divide by 3. Oh, it's 1/3. You know, as soon as you write equals 0, you'll be able to get it. You could use algebra to solve it too. All right. This part we're used to. Now, what we have to do is make sure they both have the same denominator, and we just figured out what that denominator needs to be. Oh, cool. This one already has it. But this one doesn't. Because it doesn't, we have to build this fraction up so that it does have that least common denominator. It already has the x minus 1, but it needs an x minus 2. Whatever we do to the bottom, we do to the top, because x minus 2 divided by x minus 2 is just 1. We have not changed its value, we've just made it look different. Well, let's see. If I distribute this x, that'll be x squared minus 2x over the quantity x minus 2 times the quantity x minus 1 plus 2x minus 1 over the quantity x minus 2 times the quantity x minus 1. Hey, they have a common denominator. I can finally do the addition. That's what we did all that for, so we could put the tops together. That's what we needed to see. So I'm going to put little equals in here to break up my work. And I can go ahead and add x squared minus 2x plus 2x. Hey, that's just going to be x squared minus 1 over x minus 2 times x minus 1. And see how our denominator hasn't changed? So we don't have any new domain restrictions. Unless we can simplify this. The only way we can simplify this is by canceling. Canceling is division, so we have to see pure multiplication in order to cancel. Well, the only way I'm going to see that is if this is factorable. Is x squared minus 1 factorable? It is, isn't it? That's a difference of 2 squares. So it's x plus 1 times x minus 1. Opposite signs make outside times outside plus inside times inside cancel out. Oh, now I can see multiplication. Parentheses show multiplication. So that means I could cancel if there's something that they share. What does the numerator and the denominator share in this one? X minus 1 is gone. And again, no new domain restrictions. We already took care of 2 and 1 as our problems. So there it is. Now, this is where we talked about this before you had your, what was it, 4-day break? Juniors, you got a 3-day break? You cannot cancel these x's. You can't do that because that's not pure multiplication anymore. There's addition on the top and subtraction on the bottom. And you can't undo addition and subtraction with division. That doesn't make any sense. So it stays just like that. All right, a little more practice. Let's look at 2a. It says, what's the sum? So we're going to find this addition here. And again, we need to give them the domain, the restrictions on the variables. So we have x plus 1 over x minus 1. Is there any more factoring that can be done to x minus 1? Okay, so let's look at the second one. Plus a negative 2 over, x squared minus x. What do you notice about that? Yeah, let's take an x out. Oh, that was a good thing to do because now we're going to be able to find our LCD. All right, looking just at the denominators. Any stray numbers hanging out by themselves? Any stray variables hanging out by themselves? Yep, we've got an x. And then pretty obviously they both have an x minus 1, right? Just to the first power, or was there a higher power? Okay, so now let's get our restrictions on the domain. What number would be bad if there's an x in the denominator? 0, because that would make 0 times anything 0. So 0's out, and yes, somebody already told me the 1 for the second set there, the parentheses, x minus 1. So those are out. All right. Well, hey, they're almost the same, aren't they? The first fraction just needs a little something. What's the something the first fraction needs? Just the x. So we're going to multiply by x over x. That will give us x squared plus x over x times the quantity x minus 1 plus negative 2 over x times the quantity x minus 1. Do they have a common denominator now? Well, then let's put those two numerators together. X squared plus x minus 2 over x times the quantity x minus 1. Unless x squared plus x minus 2 is factorable, and there would be something we could cancel. Well, there's no greatest common monomial factor. It's not a perfect square because negative 2 is not a perfect square. But are there two numbers that multiply to negative 2 and add to 1? Plus 2 and negative 1. So now what can we do? Yeah, cancel these x minus 1's out. So with adding and subtracting fractions, the only canceling you can do is at the end, the very last thing. When we multiplied and divided, we could cancel anytime. But with adding and subtracting, it's got to be the last thing that you do. Alrighty, what was b? X over x squared minus 4 plus 1 over x plus 2. Is x squared minus 4 factorable? Difference of two squares, right? So it'll be x over x plus 2 times x minus 2 plus 1 over x plus 2. And again, if it drives you bonkers that there's no parentheses there, put parentheses there. Those two are together. All right, LCD. What do we need? X plus 2 and x minus 2. Any higher powers? Okay, so it's those two pieces. And what would be our domain restrictions? What numbers are out? 2 and negative 2. So x cannot be plus or minus 2. Well, again, these are almost the same. Second one needs something, though. What's the second fraction need? Yep, top and bottom. So now it will be x over the quantity x plus 2 times the quantity x minus 2 plus x minus 2 over the quantity x plus 2 times the quantity x minus 2. Whew. Can we put them together now? Yeah, we've got a common denominator. So x plus x is 2x minus 2 over the quantity x plus 2 times the quantity x minus 2, unless the numerator is factorable and something cancels. Is the numerator factorable? Yes. But I saw some of you shaking your heads, so you already noticed something about this. What's the something you noticed? You're still not going to be able to cancel, right? So, Cedar Home, are we going to lose like points if we don't do this last step? Yeah, because this is the way that I know that you knew to try. You knew to factor it and see if anything would cancel out, and it didn't. So yes, we do that last step. We try to cancel at the very, very end. Alrighty, C says, is it possible to add the rational expressions in problem 2 by finding a common denominator but not the least common denominator, and explain? So here's their question. What if we didn't notice that these were all to the first power, and we put x minus 1 squared and x minus 2 squared, and we built our fractions up with that math? Would we get a different answer? No. Would we want to do that math? No. It would be a mess. So we could use a different denominator other than the least common denominator. So, is it possible? Yes, it's possible. But no, we wouldn't want to do it, because it would give, well, x to the fourths, x to the thirds, and we'd rather just work with x squareds. All right, I wanted to do one subtraction one, but nope, you know what, we'll skip that and take care of it tomorrow. We did a lot of stuff today. So, let me get you some practice. Again, not all of these are, add the fractions together. Some of these are just find the least common multiple. Find the least common denominator. So there it is. 7 through 21, 48, and 52 to 55.